Hello everyone, I'm ketaoli. I come from project group 5. Today, I'd like to report my project progress regarding Toronto crime prediction project. My report includes 4 parts. First one is the project definition. In Toronto, crime is a big concern for the citizens. The residents expect to live in a safer place, and the government wants to decrease the crime rate. So, the MCI dataset is very important for us to analyze. It's quite helpful for crime prevention if we can predict crime occurrence in advance. The machine learning prediction model is expected to be established to predict the occurrence of a crime at a location at a specific time of a day and to anticipate if a particular neighborhood in the city at any given duration of the day will be a crime hotspot or not. My project includes 2 classifiers. One is the binary classifier. In this classifier, I classify robbery and assault into severe crime type, and I classify the other MCI crime types, theft over, auto theft, break and enter, into not severe crime type. In the multi-class classifier, I'll use the temporal features, spatial features, and demographic features to predict the crime type. That means one of crimes in robbery, assault, theft over, auto theft, break and enter. Mainly, I use 2 datasets. It includes dataset 1 and dataset 2. This is the dataset description. Secondly, I do the data pre-processing. The missing data come from the older history data before the year 2014. We can get the complete data for the year between 2014 to 2019. We also merge some features from dataset 2 to dataset 1 for every neighborhood. These features include employment rate, unemployment rate, housing unsuitable rate, population, post-secondary rate, average income, and density. This pie chart shows that most crime types in the dataset are assault. Only 3% of crime type are theft over, so the dataset is imbalanced. In this pie chart, it shows that the severe crime account for 64% of the dataset. This picture shows the data analysis for crime versus time. This picture shows the crime versus location. The left picture shows the most dangerous neighborhood in Toronto, and the right picture shows the safest neighborhood in Toronto. This picture shows the assault distribution, break and enter distribution, auto-theft distribution, and robbery distribution, and theft over distribution. This picture shows the relationship between crime versus income. This picture shows the relationship between crime versus education. This picture shows the relationship between crime versus housing. This picture shows the correlation between MCI. Then we'll go on the third part, modeling. For binary classification modeling, at first I do the feature selection. I use the recursive feature elimination and the feature importance methods to do the feature selection. Both methods show that population and post-secondary are the least important features. I remove these features. Then I use the smooth to balance the dataset. After the dataset balancing, I get the balanced dataset. I use many algorithms to make the prediction. Here is the performance comparison table. From this table, we can see that the random forest is the best algorithm for my prediction. Similarly, in my multi-class classification modeling, I use the feature important method to do the feature selection. The method shows that the population and the post-secondary are the least important features. I also remove these features. I use the smooth to balance the dataset for our multi-class classification model. This picture shows the algorithm performance for my multi-class classification model. So far, I finished the exploratory data analysis, and I also created two kinds of classifiers. In my project, I use different algorithms to predict the crime type. My further work in the coming weeks. The first one, I will use the ensemble method to get the better prediction accuracy. Secondly, I will tune the parameter for some potential algorithms. Thirdly, I'll do the model interpretability. Fourthly, I'll use the unsupervised methods such as k-means and hierarchical clustering in the project. The unsupervised machine learning algorithms are used to discover new relationships between various features. Thank you.